Initially, I'm going to have the power 0, then I'm going to increment by 1. After that, once again, I'm going to increment by 1. Like that, it's going to continue. In the second example, I'm going to have integral part as well as fractional part. That's nothing but the real part. So what are the rules I want to follow? Whatever the decimal number I have, I'm going to divide that number by 8. Good morning to all. A warm welcome to my new session on data representation. I'm Revati, faculty, Department of Computer Science, Vidyashram, Pre-University College, Temple of Excellence. Before going to start my today's session, let me to recall the things what we discussed in my previous session. In my previous session, we learned number system conversion. That means how we can able to convert one number system to another number system. In that, we studied how to convert decimal to binary. But in today's class, we are going to study how to convert binary number to decimal as well as decimal to octal and octal to decimal. Instead of wasting much of time, directly get into the topic conversion binary number to decimal numbers. That means I'm going to have binary number. Now I want to convert that binary number to decimal number. For example, say I have 111. Convert this binary number to decimal. So what is the value of 31? That is nothing but 7. Now we are going to study what are the steps we are going to follow while converting binary number to decimal number. So what is the first rule? That is start at the rightmost bit. That means I'm going to consider the rightmost bit. Then step 2, take that bit and multiply by 2. That means if I want to convert binary number to decimal number, I'm going to start from the rightmost bit and I'm going to take that bit and I'm going to multiply that bit by 2 to the power n, when n is the current position. So what is the value of n? It is initially we are going to consider the current position. That means the position of the bit, and increasing by 1 each time. That means each time I'm going to increase the position by 1. This represents a power of 2. Initially, I'm going to have the power 0. Then I'm going to increment by 1. After that, once again, I'm going to increment by 1. Like that, it's going to continue. In step 3, add all the product. To get the final result, what I want to do, I'm going to add all the products. Then in the step 4, after adding, the result is equivalent to the decimal value of the binary number. So here I will take 1101. Now I'm going to consider the first rightmost bit. So what is my first rightmost bit? It is 0. Now I'll write the position. So it present at the position 0 and second 0 present at the position 1 and third one is present at the position 2 and last it is present at the position 3. So I'm going to have the positions like 0, 1, 2 and 3. Then what is the total bit size I'm going to have? It is 4 bit. So for 4 bit, I'm going to have the position 0 to 3. Now, consider the example here. I'm going to have the number that is 1010111, and it is binary number. To represent binary number, I'm going to have the base value 2. Now, according to the rule, first what I want to do, I want to find the position. According to the steps, the rightmost bit I'm going to consider. Then I'm going to write the position. For the first rightmost bit, I'll write 0, then it is 1, then 2, it is 3, it is 4, it is 5, and it is 6. So what is the length here? It is 7 bit. If I consider position, it's going to start from 0 and it's going to end with 6. Total, it is 7 position. Then what is the next step I'm going to have? I'm going to write the power of each position. And I'm going to multiply that power with the bit value. So at the beginning, I'll write the position. So 1 into 2 to the power 0 plus, I'm going to consider next bit, that is 1 into 2 to the power 1 plus 1 into 2 to the power 2 plus 0 into 2 to the power 3. Like that, it is 2 to the power 6. And now I'm going to find the power of 2. If I consider 2 to the power 0, according to the property, I'm going to have the value 1. So what I will do, I'm going to write as it is. So I'll write 1 as it is, and the power of 2 to the power 0 is 1. Then if I consider second bit, it is 1 and 2 to the power 1. So what's the value of 2 to the power 1? It is 2. So I will write 1 into 2. Now if I consider 2 to the power 2, then what's the value I'm going to get? That is 4. And I'm going to multiply 4 with 1. And it is 2 to the power 3. So what's the value of 2 to the power 3? It is 8. Then I'm going to multiply 8 with 0. If I consider 2 to the power 4, then it is 16. If I consider 2 to the power 5, then it is 32. 2 to the power 6, 64. Now I'm going to multiply all the bits. So what I will do, I'll multiply 1 into 1. I'm going to get 1. Now I'm going to have 1. 1 into 2, I'll get 2. Here 1 into 4, I'll get 4. Here it is 0 into 8. That means whatever the value, I'm going to multiply with 0. My product is 0. So I won't consider this bit. Now I'm going to consider next bit, that is 1 into 16. I'm going to get 16. Then here it is 0 into 32. When I multiply 32 with 0, I'm going to get the value 0. Then I'm going to consider the last bit, that is 1 into 64. Now what I want to do, I want to add all the products together. After adding all the product, I'm going to get 87. Now at the end, I'm going to write the conclusion or result. Therefore, I'll write the binary bit as it is, and I'm going to write the decimal equivalent. To represent a decimal value, I'm going to write the base value. So what's the base here? It is 10. Moving further, let me to take another example. For example, I will consider 1, 1, 1 and 1. According to the rule, what I want to do? First, I want to find the position. So what I will do, I'll write the position. For the first bit, I'll write 0, this one 1, this one 2, and this one 3. Then what's my next step? I'm going to write the power. That means I'm going to write the binary number power. So here I'm going to convert. To represent binary number, we are going to have 2. First, I'll write the 2 to the power 0 into 1 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2 plus 1 into 2 to the power 3. Now, if I consider last bit, it is 1 into 2 to the power 0. By the property, I'm going to get 2 to the power 0 equal to 1. So, I'll get 1 into 1 plus 1 into 2 to the power 1. That is nothing but 2 plus 1 into 2 to the power 2. How can I find 2 to the power 2? That is 2 into 2. It is 4. Plus 2 to the power 3, that is 2 into 2 into 2, it is 8. 1 into 8. Now, 1 into 1, it is 1, plus 1 into 2, it is 2, plus 1 into 4, it is 4, plus 1 into 8, it is 8. Now, I want to add the product. So, here 8 plus 4, it is 12. 12 plus 2, it is 14. 14 plus 1, it is 15. So, what is the value here? It is 15. Now, therefore, 1, 1, 1, 1 of 2 equal to 15. So, this is the decimal conversion. That means whatever the binary number I'm going to have, I'm going to convert that binary to decimal. Moving further, I'm going to have second example. In the second example, I'm going to have integral part as well as fractional part. That's nothing but the real part. So, if I consider this number, this is my fractional part and this is my integral part. To find the solution for this problem, what I will do, I'm going to consider the integral part first. I will write the position first. So, it is 0th position, 1, 2, 3 and 4. Here 1, 2 and 3. But this is my fractional part. To represent the position, I'll use -1, -2, -3 up to -n. So, first what I will do, I will write the equation for, first I will consider the integral part, that is 1 into 2 to the power 0, 1 into 2 to the power 1, 0 into 2 to the power 2, 1 into 2 to the power 3, 1 into 2 to the power 4. So, first I will find the solution for the integral part. So, it is 1 into 1. Why it is 1 into 1? Because whatever the power is 0, by the property it is 1. So, 1 into 1. Then I have 1 into 2. That is 2 to the power 1. It is 2. Now, I won't consider this one. Now, it is 2 to the power 3. 2 to the power 3 in the sense it is 8. 8 into 1. Then it is 2 to the power 4. It is 16. Now 1 into 16. So what I will do, I will write all the numbers and I'm going to add the product. So this is the product. Now I'm going to add. After adding, I'm going to get 27. Then I'll write the dot. Now I'm going to consider the fractional part. So it is -1 minus 2 and minus 3. And now I want to write the inverse. That means if I write minus 1, I'm going to consider the inverse. That is nothing but 1 divided by 2. So here I have 1 into 1 divided by 2. That is when I divide any number by 2, that is 1 divided by 2, I'm going to get 0.5. And it is 1 divided by 4, it is 25, plus here it is 2 to the power minus 3, that is nothing but 8. So 1 divided by 8, it is 0.125. Now I'm going to multiply these values with the bit. So here I'm going to get 0.5 plus 0.125 because here it is 0. If I multiply any number by 0, I'm going to get 0. Now I'm going to add these two values, that is 6 to 5. So I'll write 0.5, 0.125. So it is 5 to 6. So I will write along with 27. This is the way I can able to convert the binary to decimal. So here it is binary fractional value. Moving further, I'm going to consider same example dot 1 0. Okay, now it is 2. Now I want to convert this into decimal. So I will write it is 0, it is 1, it is 2 and it is 3. So 1 into 2 to the power 3 plus 1 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Plus this is my fractional value 1 into 2 to the power minus 1 plus 1 into, that is 0, 0 into 2 to the power minus 2. So 1 into 2 to the power 3, it is 8. 8 into 1, it is 8 plus 2 to the power 2, it is 4. 4 into 1, it is 4 plus 2 to the power 1, it is 2. 2 into 1, it is 2 plus 2 to the power 0, it's 1. 1 into 1, it is 1 plus 1 by 2, it is 0.5. So 1 into 0.5 is 0.5. Now plus 0.5. Now I will write 15.5. So this is my decimal representation. I'm going to have, after converting this binary number to decimal, I'm going to get 15.5 and it is of decimal number. Moving further, I'm going to have decimal number to octal number conversion. That means I'm going to convert the decimal number to octal number. What are the rules I want to follow while converting decimal number to octal? That is, divide the given decimal number by 8. I want to convert that decimal number to binary. What I want to do? I want to divide that number by 8. Take the remainder and record it on the right side. Now repeat the step 1 and step 2 till the decimal number cannot be divided. While writing the output, I am going to consider the MSB bit to LSB bit. So what are the rules I want to follow? Whatever the decimal number I have, I'm going to divide that number by 8 and I'm going to write the remainder. And I'm going to continue this division process until that the decimal number cannot be divided further. And while writing the solution, I'm going to consider the MSB bit first and I'm going to move towards LSB bit. Now consider the example here. So according to the example, what's the value I have? It is 3034. It is my decimal number. Now I want to convert this decimal number to octal. Then how can I? For that reason, I'm going to divide this number by 8. So it is 8 threes are how much? It is 24. 24 minus 30, it is 63. Now 8 sevens are. Then whatever the remainder you're going to get, in that I'm going to write the 4. So now I have 6, 6, 3. It is 63. Now 8 sevens are 56. So it is 13, 7, 9. It is 7, 4. So 8 nines are, it is 72. Then 2 is the remainder. Now once again, I'm going to divide this number further. Now I have 47. So 8 fives are 40. What is the remainder? It is 7. Now while writing final output, I'm going to start from MSB bit to LSB bit. So it is 7, 3, 2. So we got, what's the value? 5, 7, 3, 2. So this is the octal equivalent. That means this is the decimal number I'm going to have after converting decimal number to octal. This is my octal representation. Now consider the another example. Here I'm going to have fractional decimal number. Now I want to convert this fractional decimal number to octal. And how can I convert? For that, I'm going to multiply that fractional value by 8. So when I multiply this value by 8, I'm going to get 2.50000. And I'm going to consider the carry. So what is carry here? It is 2. Now I'm going to consider rest of the fractional part, that is 5000 into 8. That means I'm going to multiply once again 8. Now I'm going to get 4.0000. In that 4 is my carry. So what I will do? I'll keep separately. Now here I have only 4 zeros, and if I multiply this 4 zeros by 8, I'm going to get 0 itself. So what I will do? I'm going to consider this carry as my output. That means I'm going to start writing the final solution by MSB bit to LSB bit. So it is 0.24. So here, what is my decimal number? It is 0.3125. And if I convert that fractional decimal number to octal, then it is 0.24 and it is my octal representation. Moving further, I'm going to have conversion, that is octal number to decimal number. Now I'm going to have the octal number. Now I'm going to convert that octal number to decimal. So start at the rightmost bit. That means how can I convert this octal to decimal? For that, I'm going to start at the rightmost bit. And I'm going to multiply each bit with the power, that is a to the power n. Now, to find the n position, I'm going to consider the position. Initially, position starts from 0 and it's going to vary n minus 1. That means to get all the bits final position, it is n minus 1 because position starts from 0. So, for that reason, n minus 1. Then, what I want to do? I want to add all the products. After adding, I'm going to get the final decimal value. So, what are the rule? First, I want to find the rightmost bit. After finding rightmost bit, I want to find the position. Now, what I want to do? I want to multiply individual bit with the power value. How I'm going to get the power value? That is, it is octal. So, here it is 8. 8 to the power 0, 8 to the power 1, 2 until n minus 1. Because why it is n minus 1? We are going to start from the 0. For that reason, it is n minus 1. After that, I'm going to add all the products to get the final result. Now, consider the example here. I'm going to have 5, 7, 3, 2. To convert the octal number to decimal, what I'm going to do? I'm going to consider individual bit and I'm going to multiply by 8 along with its position. So, here I'm going to have 4 bits. So, what is my position? It is 4 minus 1. It is 3. So, it starts from 0, 1, 2 and 3. Now, here I'm going to have 2 into a to the power 0, it is a to the power 1, a to the power 2 and a to the power 3. So, a to the power 0, it is 1, a to the power 1, it is 8, a to the power, it is 64, a to the power 3, that is 8 into 8 into 8, I'm going to get 512. Now, I'm going to multiply with individual bit, that is 5 into 512 plus 7 into 64 plus 3 into 8 plus 2 into 1. So, I'll get 2560 plus 448 plus 24 plus 2. I'm going to get 3034. So, this is my decimal representation. I'm going to have another example. So, here I'm going to have integral part as well as fractional part. So, at the beginning, I'm going to consider only integral part and I'll write the position. Later, I'm going to consider the fractional part. So, here it is 3 bit. Now, 0, it is 1 and it is 2. So, a to the power 0, a to the power 1 and a to the power 2. Now, a to the power 0, it is 1, a to the power 1, it is 8, a to the power 2, it is 64. Now, I'm going to multiply with 2. So, 2 into 64, 3 into 8 plus 4 into 1. So, I'll write my final product. Now, I'm going to consider the fractional value. So, it is minus 1 and it is minus 2. So, what I will do? I'll write as it is. If I consider 8 minus 1, that is a to the power minus 1, I'm going to convert into inverse. That means I'm going to consider the inverse, that is 1 divided by 8. So, when I perform 1 divided by 8, I'm going to get, that is 0.125. Now, I'm going to multiply this with the value 5 and if I consider 2 to the power minus 2, that is 1 by 64. When I perform 1 by 4, I'm going to get 0.09375. Now, what I will do? I'm going to add my integral part first, then I'm going to add my fractional part later. So, I will add my integral part, that is 156 dot. So to represent my fractional value, I'm going to use dot. Then I will add these fractional point. After adding this fractional part, I'll get 71875. Here I have octal number, and what is the decimal representation? It is 156. So dear student, in my today's class, we discussed how to convert one number system to another. So we started how to convert binary number to decimal and octal to decimal and decimal to octal. I hope in my today's session you got more information about number system. Let's meet in the next session with some more information about data representation. Until then, keep watching and keep learning. Thank you.